Welcome to the deep dive. Today, we're diving into, well, a really fascinating idea. Hollow planets.
hmm
You see it pop up everywhere, right? Ancient myths, tons of science fiction, and even some pretty wild modern theories.
It definitely captures the imagination, this idea of massive worlds, maybe with something hidden deep inside.
Exactly. So our mission today is to explore this. Are planets, naturally hollow? Could we actually make one hollow? And what would that even mean?
Yeah, let's peel back the layers, you could say. See what science tells us versus, well, what our imaginations conjure up.
Okay, where do we start? Maybe with the history. Because this isn't a new idea, is it?
Not at all. It's got really deep roots. Think way back ancient Greece. Hades wasn't up in the clouds, was it?
No, it was the underworld beneath
Well,
us.
right. Down below. A
Mhm.
whole realm under the Earth's surface. And you see similar things elsewhere, like in Hindu cosmology, there's Patala, a subterranean world supposedly full of, amazing beings, treasures, that kind of stuff. Not science, obviously, but it shows this long-standing human fascination with what might be hidden inside our world.
It's more than just myths, though. Didn't a famous scientist actually propose something like this?
You're thinking of Edmund Halley.
The comet guy.
That's the one.
Yeah.
Back in the 17th century, he seriously proposed a hollow Earth. Not just hollow, but with multiple shells inside, kind of like an onion.
Shells.
Yeah, concentric shells, maybe even with their own atmospheres, and get this, a little sun glowing at the very center.
Wow. Okay, so a major scientific figure was genuinely exploring this. Why?
Well, he was trying to make sense of things they couldn't explain back then, like weird compass readings, variations in magnetism. His model was, let's say, creative.
But ultimately wrong, I assume.
Oh, definitely wrong based on what we know now, but it shows the idea wasn't just pure fantasy even then. And then, moving closer to our time, the whole Hollow Earth thing gets tangled up with conspiracy theories.
Ah, right. Like secret Nazi bases down there.
Exactly that. Or hidden cities like Agartha, maybe even subterranean alien civilizations pulling the strings. It's taken quite the journey, this concept.
Okay, so that's the folklore and the fringe side. Let's pivot to the hard science. What do we actually know about what's inside a planet like Earth?
Right, the evidence. Our best tool for that is seismology, studying earthquake waves.
How they travel through the planet.
Precisely. Think of it like a planetary ultrasound. These waves, they ripple right through the Earth, and how fast they go, where they bend, where they get blocked, that tells us what they're moving through. Is it solid, liquid, dense, less dense?
And this gives us a pretty detailed picture.
Incredibly detailed now. There was landmark work, Dwanski and Anderson back in '81, that gave us what we call the pre-model. It's like a blueprint of Earth's interior.
Okay, so lay it out for us. What does this blueprint show? Forget the inner sun for a second.
Yeah, no inner sun. What it shows is layers. We're standing on the crust, which is surprisingly thin, relatively speaking, maybe a few kilometers thick under oceans, up maybe 70 under big mountain ranges.
Okay, thin crust.
Then what? Then you hit the mantle. That's the really big layer, thick rock. Goes down almost 2,900 kilometers. It's mostly solid, but behaves kind of like a very, very slow-moving fluid over geological time.
Right, plate tectonics and all that.
Exactly. Below the mantle, things change dramatically. You hit the outer core, and the seismic waves tell us this part is liquid.
Liquid metal, right, iron and nickel.
Mostly iron and nickel, yeah. Super hot, swirling around, and that's actually what generates Earth's magnetic field.
And inside that.
Right at the very center, the pressure is so immense that even though it's incredibly hot, the iron and nickel solidify again.
Yeah.
That's the solid inner core.
So layers. Solid, liquid, solid, no big empty space.
None whatsoever indicated by the data. The way those seismic waves behave, especially the shear waves or S waves, which can't travel through liquid, it paints a very clear picture of a dense, layered interior, not a hollow shell.
It sounds like the way planets form makes being hollow pretty much impossible naturally.
That's the scientific consensus, yes. Gravity is the key player. When a planet forms, gravity pulls all the dust and gas and rock together, crushing it inwards. Denser materials sink to the center. Lighter stuff floats toward the surface. It's a process that inherently leads to a dense core, not a void.
Any large empty space would just collapse under the sheer weight.
It would, inevitably. The gravitational pressure is just too enormous for a large void to remain stable.
Yeah.
Think of trying to have a big air bubble at the bottom of the ocean. The water pressure would crush it instantly. Same principle, just, rock and metal on a planetary scale.
Okay, so nature doesn't seem to make hollow planets. But could we? Or could something else?
Well,
Theoretically.
now we're moving into the realm of speculation and, frankly, megastructure engineering. It's a fun thought experiment.
What are the big hurdles?
The biggest one is material strength. To hold open a hollow space inside something as massive as a planet, resisting all that gravity pulling inwards, you'd need materials with, well, almost unimaginable tensile strength. Strength far, far beyond anything we know how to make.
Strong enough to stop a planet collapsing in on itself.
Exactly. And then there's the weird physics inside. You mentioned Newton's shell theorem earlier.
Vaguely. Something about zero gravity.
That's the one. Inside a perfect, uniform hollow sphere, the gravitational pull from all sides cancels out. So right in the middle, you'd be weightless.
Sound kind of cool.
It does, but it also points to the instability. That zero-G spot exists because of a perfect balance of immense forces all pulling inwards. Any imperfection, any slight density variation, and things would likely go very wrong. That void would want to collapse unless something was actively pushing outwards.
Active support. Like advanced technology holding it open.
Precisely. We're talking forces on an astronomical scale.
Yeah.
It makes you think about other theoretical megastructures, maybe like Dyson shells.
Freeman Dyson's idea, building a sphere around a whole star.
Right. Not a hollow planet, but a massive artificial hollow structure nonetheless. Dyson's concept was about capturing all of a star's energy. The sheer scale required for that gives you a sense of the kind of civilization, the kind of technology you'd need to engineer anything on that scale, including actively maintaining a hollow planet.
So natural formation is a no-go, but artificial construction is, well, theoretically conceivable for some super advanced civilization, maybe.
Maybe. It pushes the limits of known physics and engineering, but you can't rule it out completely in the realm of the truly advanced hypothetical.
Which probably explains why the idea sticks around so much in fiction. Science says no, but our imagination loves it.
Oh, absolutely. It's a staple. Jules Verne's Journey to the Center of the Earth is probably the most iconic example. It just fires up the imagination.
And comics too, right? Didn't DC have a whole world inside the Earth?
Scartoris, yeah, dinosaurs, magic, the whole deal hidden away down there. And then you've got things like the Halo ring worlds in video games. Not planets, sure, but enormous structures with habitable inner surfaces. Fiction keeps exploring the what-ifs.
It feels like that what if is starting to leak back into more, let's say, grounded thinking now. Not hollow earths, maybe, but related ideas.
That's a great way to put it. Engineers and futurists are definitely looking at related concepts, but bringing the scale down to something potentially achievable.
Like what?
Well, instead of hollowing a whole planet, what about using natural large caverns? Or maybe hollowing out smaller bodies like asteroids?
Asteroid colonies inside the rock.
Exactly. Imagine carving out the interior of a decent-sized asteroid. You'd have built-in radiation shielding from the rock itself. That's a huge advantage over surface habitats.
And maybe terraforming, but inwards, making dead moons usable from the inside.
That's another angle people are exploring. Taking a smaller body, maybe like Phobos, one of Mars's moons, or a dwarf planet like Ceres, and creating habitable environments within them. The engineering challenges are still immense, of course, but seem less astronomical than hollowing out Mars.
So the idea shifts from hollow planet to hollowed habitat.
Precisely. And the benefits are compelling when you think about long-term space settlement.
What are the big advantages of living inside an asteroid or moon versus on the surface?
Okay, number one, like we said, radiation. Space is full of nasty radiation, cosmic rays, solar flares. Having kilometers of rock and ice above you is the best shield imaginable.
Better than anything we could build on the surface easily.
By far. Then there's temperature. Surfaces of moons and asteroids swing wildly between extreme heat and cold. Inside, you could maintain a much more stable, controlled thermal environment.
Makes sense. Easier insulation.
And maybe even holding on to an atmosphere. Pressurizing a sealed internal volume might actually be more efficient and safer than trying to maintain pressure under a dome on the surface, which is vulnerable to impacts and leaks.
It's interesting. We're already kind of looking at this with lava tubes, right? On the moon and Mars.
Yes, that's a crucial stepping stone. These natural tunnels, left over from ancient volcanic flows, they offer some of those same advantages: natural shielding, thermal stability. NASA and others are seriously studying how we could use lava tubes as ready-made shelters.
So that research could directly feed into how we might eventually hollow out larger spaces ourselves.
Absolutely. It's all part of the same progression, learning to live and work beneath the surface, from using natural caves to perhaps one day excavating purpose-built habitats inside celestial bodies.
Wow. So this idea that started in myth, went through science fiction, now it's circling back to actual potential future engineering, it really does have a hold on us.
It really does. And I think, there's a deeper appeal too, something almost philosophical. Well, think about exploration. We always look outwards, up at the stars. The hollow world idea flips that. It's about exploring inwards, discovering hidden depths, secret worlds within. It's kind of like a metaphor for exploring our own subconscious, maybe. The
Yeah.
unknown within the familiar.
That's a neat way to think about it. The allure of the hidden. It makes you wonder about what reality is, what's possible. Maybe the future isn't just colonizing surfaces.
Maybe it's about carving out niches within other worlds, finding safety, resources, maybe even life in places we haven't really looked yet beneath the surface. Picture communities thriving inside Ceres or Ganymede, protected by ice and rock.
It's a very different vision of humanity's future in space. So, wrapping up this deep dive, these questions really remain, don't they? Are hollow worlds purely fantasy, forever confined to stories? Or could they represent a genuine, if distant, frontier?
Could we shift from terraforming surfaces, which is incredibly hard, to terraforming inwards? Is that even crazier? Maybe potentially more practical in some ways.
And should we be putting more effort into looking down when we explore other worlds? Not just for geology or resources, but for shelter, for history, maybe even for life hidden away from the harshness of space.
These are the big thoughts sparked by this seemingly simple sci-fi trope. It really pushes us to think differently about space, about habitation, about where the next great discoveries might lie.
Well, thanks for digging into this with me. It certainly gives you a lot to think about. Makes you wonder if the answers we're looking for aren't always out there, but sometimes, maybe right beneath our feet.